One final note about hybrid orbitals before we move on to our next topic is that hybrid orbitals are not necessarily what we would call the truth of what's exactly going on with the electrons in a molecule. So for example, in something like methane, right, we've constructed these sp3 hybrid orbitals, and this is a very useful approximation. It's used a lot by organic chemists, right, to figure out what shapes molecules are generally sort of going to take as something sp3, sp2, sp hybridized. But what's usually really happening in something like, say, methane, is that we don't have these orbitals that are localized, on just, say, one bond, as we would predict from an sp3 hybridization scheme. The sp3 hybridization scheme it's more of a mathematical way to sort of justify the geometries that we experimentally observe for these molecules. So that's usually not what's happening. There's usually not localized orbitals. Instead, what we'll see is a symmetry adapted linear combinations of atomic orbitals that sort of spread over the entire molecule. So for methane, we may see sets of orbitals where the electron density goes across the entire molecule. And that's not something that would necessarily be predicted by an sp3 hybridization scheme. So just a word about that to let you know that this hybridization scheme that we've been talking about, this is just one way of looking at molecular orbitals. If you want to get closer to what the truth of what these orbitals really look like, what you really need is something like computational chemistry, right, where we can actually use variational theory, perturbation theory, to try to solve the actual Hamiltonian for the entire system, right, for all the electrons, all the nuclei that are present. It's not easy to do by hand, but computers, we've developed algorithms that we can use to apply perturbation theory and variational theory, starting from the atomic orbitals that we've been looking at, combining those to form molecular orbitals. So just to note on that, we've been talking about these hybrid orbitals, but the reality is, of course, more complicated.